It's French. L'Hôpital was a French guy. That's why it's L'Hôpitals or Los. It looks like L'Hospitals, but it's really L'Hôpitals. That was his name, L'Hôpital. Okay, so the S, sometimes they put the S, sometimes they don't. Doesn't matter, it's silent. We don't say it. Okay? So L'Hôpital's rule is a theorem. It's a rule. And it's one of those things, it's kind of like the golden ticket for limits. Okay, it's kind of like the golden ticket for limits. So when do you use L'Hôpital's rule? When you're trying to find a limit. Well, we were doing limits in August. So why didn't Mr. Flores teach you this in August? Because in August, you had no idea what a derivative was, right? You didn't know what a derivative was. And L'Hôpital's rule, you need to know what a derivative is, okay? So I don't really put it in the derivative units because it's not really a derivative. We use derivatives, but it's not a derivative thing. And I don't include it in the limits portion because you have no idea what a derivative is. When we did limits, some of you probably had never heard of what a limit or a derivative was. And those of you that have maybe didn't really know what it was. So I couldn't put it in limits. So it kind of is one of those things that kind of lives in a couple different areas. So when do we use L'Hôpital's rule? Only when we're doing limits, okay? And it's kind of, since you already know what a limit is and you already know how to find derivatives, I usually do it the first day back because it's kind of an easy lesson in. It's not that hard because you've seen all this stuff before, okay? Okay, so what is L'Hôpital's? When do we use L'Hôpital's? When we're finding the limit. And what's the first thing we do? So if we have a limit question, we have a limit problem, any of these guys, what's the first thing we always should do when we're solving a limit? Plug it in. Plug it in, right? If we get a number, we're done. Move on to the next problem. If we get, a lot of times what happened is we got an indeterminate form. So indeterminate form means 0 over 0 most of the time, right? Or some sort of infinity over some sort of infinity. So a lot of times students see infinity over infinity, isn't that just 1 or -1? No, because infinity is not a number, okay? If infinity were a value, like a number, I could plug it in my calculator, then yeah, it would be 1. But infinity is not a number, so it's considered indeterminate. The reason they call it indeterminate is because what's the rule? If I have a fraction, if I have a fraction, and I have 0 on top, what's the rule for that fraction? What is it always going to equal? 0, right? 0 on top. Doesn't matter what's on bottom. Doesn't matter positive, negative, decimal fraction. Doesn't matter what it is, it's always going to be 0, right? And what if I get 0 on the bottom of a fraction? What's the rule? What's that always going to be? Undefined, error, one of those guys, right? Undefined, error, however you want to think about it, right? Well, here's a question. What happens if you get a 0 on top and a 0 on bottom? Is it 0? Is it undefined? I don't know. We don't know. That's why it's called indeterminate. Okay? All right. So anytime we get one of those guys, you can use L'Hôpital's rule. L'Hôpital's rule says, do what you guys did, plug in the number. If you get 0 over 0 or some kind of infinity over infinity, find the derivative of the top, find the derivative of the bottom, plug it in back again. If you get 0 over 0, find the second derivative, plug it back in. Keep going until you get an actual answer, okay? So if I were to plug in, so first example, if I were to plug in 2, right? I know I'd get 2 on the bottom, right? Or sorry, 0 on the bottom. I know I get 0 on the bottom. On top, if I plugged in 2, let's see, 2 squared, let's see. Let's see, 12 minus 5 times 2 is 14 plus 2, right? 5 times, 2 times, 7 times 2 is negative 14 plus 2. I said it wrong, wrote it right. Okay? So we get 0 over 0, right? Last semester, when we did limits, we said, we would probably say factor the top. Factor the top, it's a trinomial, factor it. And then see if anything cancels out, right? You could still do that. That still works. Same thing we did last semester still works. but I think using L'Hopital's is a little easier. So what L'Hopital says is if you get an indeterminate the first time, find the derivative. Okay, so let's same limit. Find the derivative of the top function. So that would be 6x minus 7. Find the derivative of the bottom, which is just 1, right? Plug it in again. 6 times 2 is 12, minus 7 is 5. 5 over 1 or 5. Oops, this should be a 2. Okay? So from now on, when you get a limit and you get 0 over 0 or infinity over infinity, use L'Hopital's. Let me show you a time when L'Hopital's won't work. Because all of these, L'Hopital's will work. So let me show you an example where L'Hopital's won't work. And this is an example I think we had last year. This example here. Why won't L'Hopital's rule work for this guy?
Well, first of all, you're not going to get a 0 over 0.
There you go. You won't get 0 over 0, right? What happens when I plug in 1? I get 1 over 0. That's not indeterminate, right? That means there's an asymptote at 1 and I have to investigate it, right, further and do all that stuff. So if you get something over 1, or sorry, something over 0, L'Hopital's does not apply. It only applies when you get 0 over 0, okay? So just be careful with that. Okay. All right, so let's plug it in. We know we're going to get 0 on top. Let's see the bottom. So I get negative 3 plus 3, right? And then square root negative 3 squared minus 5 in the parentheses minus 2. So negative 3 squared is 9, minus 5 is 4, square root of 4 is 2. So 2 minus 2, we can use L'Hopital's rule. Especially for this problem, anything with a root, L'Hopital's is where you're going to save a lot of time versus what you did last semester. What we did last semester was we had to multiply the top and the bottom by the conjugate of this guy. And that became ugly. It was possible, but it just became a longer problem. Now we're going to take this problem and make it a little shorter, okay? So let's find, first thing I got to do is find the derivative of the top and the derivative of the bottom. Well, the derivative of the top is just 1. Derivative of the bottom is going to be a little bit more, not hard, but it's going to be not as easy. Okay. So we have x squared minus 5 to the 1/2 power, right? Minus 5, or minus 2. Right, that's what it really is. Anytime we're doing derivatives, remember we need a power. No root, power. So the derivative of negative 2 is 0. So I'm not really worried about the minus 2 part because the derivative there is just going to be 0. I'm going to find the derivative of this part here. Right? What am I going to use? Which tool am I going to use? Which rule am I going to use to find derivative of that guy? Chain rule, good. Okay. So chain rule says, move the power to the front, subtract a power, multiply by the derivative of the inside. The derivative of the inside parentheses is just 2x. So on bottom, I get 1/2 x squared minus 5 to the negative 1/2 times 2x. I can simplify that a little bit. I can simplify that guy a little bit, right? The 1/2 is a coefficient. The 2x is a coefficient. I can multiply 1/2 times 2, you get positive 1. So it becomes 1 over x squared minus 5 times x. You can move the x to the front too. Oops, negative 1/2. Oops, should be negative. And then you could simplify it a little bit further. Negative powers mean what? How do we change that to a positive power? Move it up, yep. Move it up to become positive. So that's going to be, and then we can give it its square root back. That's usually when I give it its square root back is when the power is positive. And then x remains on the bottom though because that had a power of positive 1, so it stays. That's the derivative of both the top and the bottom. Okay, let's do it again. The limit as x approaches negative 3. So I have square root x squared over negative 3. So negative 3 squared is 9, minus 5 is 4, square root is 2. There you go, negative 2/3.
Also minus 2, or
No.
because it's either plus or minus 2, right?
No.
No, when you're simplifying like that, no, yeah, good answer. Good question. So when I take a square root, when is it going to be a positive version and a negative version? That's when you're solving. So when I'm solving, if I was solving an equation, then yeah, I would need to do that. But anytime you're plugging it in, we always just do that's a good question, yeah. Because yeah, it can be confusing. Like when you take, like sometimes when we're taking like square root of 64, and you're like 8. But sometimes we do plus and minus 8. When do we do plus and minus versus just the positive? When we're solving for x, always do plus and minus, because there is 2 answers. But when we're just plugging in numbers like that, just the positive. Positive's good. Okay. All right. Let's look at do number 3. If you haven't already, do number 3. I'll give you a hint. It's going to be 0 over 0.
No way.
No way.
But I wanted to do.
Yeah, go for it.
All right.
Okay, yeah. So if you plug in 0 or negative 2 on top and on bottom, you eventually do get 0 over 0. So we got to find first derivative.
This is
3x squared minus 2x minus 8. 3x squared plus 16x plus 20. Oh, plus 2x, yeah. Yep, plus 2x, yeah. Okay. 3 negative 2 squared minus 2 negative 2 minus 8. 3 negative 2 squared plus 2. Okay, why did I do that again? 16 minus 2 plus 20. All right, let's see. Let me move this down a little bit. See what we get. 12 minus 4 minus 8. That's 0. And then we get 12 minus 32 plus 20. That is 0 over 0.
Now I think I know why you asked us to do it by ourselves.
Second derivative. What happens then? Second derivative. 6x plus 2, 6x plus 16.
I'm gonna say it now. There's no way we're getting 0 over 0.
Never say never.
It's plus 2 or plus 16.
Nah, watch.
No, you forgot about the numbers.
Okay, so we got negative 12 plus 2 is negative 10. Negative 12 plus 16, positive 4. Negative 5 over 2.
Yay.
So sometimes you might need to go to the second derivative. Okay?
Does that also mean we could possibly go to the third derivative?
Yes, it does.
Oh, no.
Yes, it does. Yes, it
Fourth
does.
derivative.
On the
Okay.
it's just one of these to like 10th derivative.
The only
So
time,
how do you get so pointless to have multiple like
the only time where you're going to have something that keeps going and keeps going is when you have mainly sine and cosine. Because sine and cosine, its derivative are the same, right? And that's what we got here.
What a coincidence. Ace did that prepare us enough for trigonometry.
What a coincidence.
All
No,
right.
we did not. We were too-
Let's see. Let's plug in 0.
And he made it seem so
Oh, we need the circle.
I know, he made it seem like it was just nothing. Like he lied.
2 times sine of 0 minus sine of 2 times 0.
So 2 times 0.
0 minus 0 times cosine of 0.
Wait, what is sine 0?
So sine of 0 is 0. So this is 2 times 0.
But it's times 0, man.
And then sine of 2 times 0 is sine of 0, which is a 0 again. So it looks like we're going to get 0 on top. And it looks like 0 on bottom as well. Oh, it's 0 times 1, but that's still 0. All right, so here we go. Derivatives. Okay, so let's do derivatives. I'm going to do top first. So derivative 2 times sine of x. 2 times sine of x is just going to be 2 times cosine of x. Minus. This one I'm going to need the chain rule because it has a 2x on the inside and not just an x. So derivative of sine is cosine 2x times the derivative of the inside, which is 2. Okay, so let me write this down. Limit x approaches 0. Okay. Now the bottom. Derivative of sine is cosine, so cosine of x. Yeah, so the next one is going to be product rule, because it's x times cosine of x. So product rule says the first times the derivative of the second. Derivative of sine is negative, or derivative of cosine is negative sine, plus the opposite. Derivative of x is 1 cosine. So we got to distribute that negative, though, to here and to there. So it's going to be cosine of x plus x times sine of x minus cosine of x. That's the derivative. The nice thing about these is you can plug in 0 in your head, because cosine of 0 is 1. Sine of 0 is 0, okay? So you can kind of do that in your head. So am I going to get 0 over 0, or am I going to get something other than 0 over 0? I honestly don't know because I need to check my notes. I can't remember.
Then 0.
Oh no. Oh no. I have no idea if I'm the second derivative of this.
Here we go. Yeah, I do get 0 over 0. So we find the derivative, right? We find the derivative again. Now, I'm not going to make you do it because you guys spent all last semester doing it. But if you were to get this question on a test or a quiz, you guys know what to do, right? Or an assignment. So you would find the derivative of that and then keep going until you get, eventually you will get something where you get, I think it's the next derivative, but like I said, I'm not going to, you kind of get the idea. Because 2 times 1 minus 2 times 1 And then on bottom, you get 1 plus 1 time, or 0 times 0, and then minus 1, right?
Yep.
So you get 2 minus 2, which is 0. And then you get 1. You get 0 times 0, which is 0. So 1 plus 0 minus 1 is 0. Okay, and then you would find the second derivative and do it again. I'm not going to make you do that, like I said, because just for time purposes. I'm not going to make you guys do that, but that's how you would do it. Okay? Yeah, we only got about...
Cool, let's do it in affinity
Oh, I
mode.
forgot this.
Oh, I see the E. I see the E. It's,
You know what?
you get the day.
You know what? I'm not. Let's not start this one because we only got 3 minutes and change. So we'll start with number 5 tomorrow.
Okay. That
It's not a hard problem, but I don't want to get started with it when the bell's going to ring in, like I said, 3 minutes and change.
I was waiting for you to just lie and just say, okay, we're gonna do the E one. I'm like, darn.
We're actually productive, I know. We did
What is
something.
this?
We're so unproductive.
What
We're
is
at school.
this?
Unproductive people.
Oh
We're getting
no.
nothing done, and yet
Sarah needs a lot of that.
the magic of life, we do nothing.
No way, dude.
We're here,
That'd be a-
Who makes things at 10? Like, I don't start working till 10. I'm fine right now, but once, like, yeah, I know. Actually, no, I'm not fine, because I practice. Not good, guys.
What? Are you talking about Shaw? Come on.
No, I'm not talking about that. That's like least of my concerns right now.
Well, why are you doing work at 10?
Because I get assignments to do, the assignments are due at 10.
Why?
Kind of, why are you doing it a day of?
Cause. Okay. I mean, I don't, but I'm
Okay,
just
let's
saying, like,
see.
if I did do
Okay.
the day of, like, I would have
Practice
to
is
cover.
done at